Hello students, welcome to lecture 12 of our online chemistry classes. In last class we have completed the theory part of the solid state and we are solving the numericals. There is a numerical question back. It is there in your notes also. So we are solving those questions. We have almost completed all questions, only 2-3 are left out. We'll see that also. Now question number 14 in our this question bank. I will write one here because this is today's first question. Because 13 we have solved in last class. There is a compound which forms hexagonal close packed structure, HCP structure. What is the total number of voids in 0.5 mole of it? How many of these voids are tetrahedral voids? So as there is 0.4 mole, half mole, so we can calculate the number of molecules. We can say total number of spheres, total number of spheres means particles is equal to 0.5 mole, that is half mole, and half mole means half into Avogadro number. So it is 3.011 into 10 raised to 23. So this is the value of n, number of spheres. So you can say total number of octahedral voids is equal to same number of spheres, which is 3.01 into 10 raised to 23. Total number of tetrahedral voids, 2 times of these particles, 2 times of 3.011 into 10 raised to 23, which happens to be equal to Avogadro number. And they also asked so this is total number of tetrahedral voids. They asked how many of them are tetrahedral, that is the question they asked. And total number of all voids nothing but octahedral voids plus tetrahedral voids. Octahedral voids are 3.011 into 10 raised to 23. Tetrahedral voids are 6.022 into 10 raised to 23. If you add them together, 9.033 into 10 raised to 23. These are the total number of points. And out of that, tetrahedral voids are 6.02. So this is very simple answer. The next question is question number 15. Which of the following lattice has the highest packing efficiency? Simple cube, which is 52.4%, body centered cube, which is 68%, and hexagonal close packing, which is 74%. So answer is HCP with 74%. Question number 16 is I think we have already done that question in the density questions. Question number 17 also we have completed in last class. Question number 18. Question number 17 is regarding that metal deficiency defect. We have seen that question already. The answer is with you. In last class we have done that. Question number 18. Aluminium crystallizes in cubic close packed structure, which is like FCC. They have given the metallic radius and they ask what is the length of the side of the unit cell. Means they ask A. And how many unit cells cells are present in 1 cubic centimeter of aluminium? So question number 18 I am solving now. I think I need not to write that question again, because till now you have obtained these notes. These notes are before you and you can see the question in your notes. So I will not write that question once again from the board. If you are not yet taken notes, you take it from college and see which question I am referring. Question number 18 of our question bank. Numerical question bank. Aluminium crystallizes in a cubic lattice, cubic closed packed structure. So you can say CCP, which is nothing but FCC, 4 times of radius is equal to square root of 2a. And they are asked about the head's length. So a equals to 4 times of radius divided by square root of 2. 4 times of the radius they are given, which is 125 picometer, and square root of 2 is 1.4142. If we simplify this, this is 353.55 picometer. 55 picometer. This is the head's length. In part B, they ask how many unit cells are there in 1 cubic centimeter. So you can say volume of 1 unit cell. Volume of 1 unit cell is equal to A cube. A already we have obtained 353.55 cube of that in picometer. We have to convert that in cubic centimeter. 353.55 into 10 raised to minus 10, and we can write it as raised to 3. We'll take cube of 353.55, which is 44192,902 into 10 raised to minus 30. Of course, we can place the decimal point here as 4.4192902 into 10 raised to 1, 2, 3, 4, 5, 6, 7. So it is minus 23, isn't it? And we can write cubic centimeter. So we can say in this cubic centimeter, 4.4192 10 raised to minus 23 cubic centimeter, there is 1 unit cell. In 1 cubic centimeter, how many units? That is the question they are asked. So we can say that number of unit cell in 1 cubic centimeter. Number of unit cells in 1 cubic centimeter of aluminium is equal to 1 divided by 4.4192 into 10 raised to minus 23. We can make it plus 23, and we can write 2.62 into 10 raised to 22. This is the answer we'll get after this simplification. So all these questions, numerical question bank, here it is written as problems. We have solved that. 3 more questions already we have done it. Question number 19 we have done in last class. 20 and 21 also we have done already. So all these 21 questions we can say that we have completed in classroom. Only thing is you have to search in notebook, because the serial number may not match there, because I don't know whether you have these notes with you or not. Many students are not taking notes from college. They are not taking that trouble also to come to college and take printed notes. Let it be. If you have notes, you might have understood that we have completed these questions. Now there is a theory question bank from PU board examination. crystallizes in FCC structure. This is the exact question they asked in March 14. Calculate the packing efficiency in simple cubic unit cell. Already we have done it. What is Frankel defect? Give an example. We have already done it. July 14. Calculate the number of atoms in FCC crystal. Calculate the packing efficiency in simple cubic lattice. What is Frankel defect? Give an example. Already we have done all these questions. There are some questions like on the electric and magnetic property here. You leave that question because already I have told you that electrical and magnetic property is not included in our this year's syllabus. So you should not worry about it. For example, in July 17, how is ferrimagnetism arises in substance? Give an example of substance showing ferrimagnetism. You should not worry about this question for theory. And for MCQs also, at least for KCT and NEET, when the syllabus is clear, I have told you that we will have one more session. If it is included, we have time, don't worry about it. But for time being, I don't want to overwork you, overburden your study. That's why I am not taking this. Otherwise, there is no issue regarding that. Now, there almost all numericals also, previous question paper we have solved. But 4 numericals we should solve here. First is from March 19. March 19. Lithium metal has a body-centered cubic lattice structure with edge length 352 picometer. Calculate the density of lithium metal. So they asked about density. March 19 question I am solving now. Because all numericals also you can see in our question line, they are already covered. So 95% questions, previous questions we have solved. 5% might have remained. You have to search and solve that also. So the question which I am solving now is March 19. And question number 45 in our this numerical question bank. They said that it is in BCC. So this number of particles per unit cell is 2. And edge length is 352 picometer. 352 picometer. Calculate the density. dy to calculate. And we know that this 352 picometer is nothing but 1 picometer is equal to 10 to minus 12 meter. And 1 meter is equal to 100 centimeter. We can convert that into 352 into 10 to minus 10 centimeter or 3.52 into 10 to minus 8 centimeter. So you can calculate this J is equal to Zm by A cube into Avogadro number. This is 2. They have given the atomic mass of lithium is 7. A cube is 3.52 cube of that into 10 to minus 8 cube of that. Now Avogadro number is 6.02 into 10 to 23. This is 10 to minus 24. Minus 24 minus plus 23. This 10 to minus 1. This equals to 10. So it is 140. 140. 3.52 square cube of that is 43.61 into 6.02. If we simplify this, the answer is 0.533 gram per cubic centimeter. this is the answer for this density. So this is question number 45 in our question bank, which has been asked in March 19. Now there is a question in June 19. You can solve that also. Metal with atomic mass 209 crystallizes in a simple cubic lattice. What is the edge length of its unit cell? Density has been given in question number 48. So we can solve that question also. It is June 19 and question number 48b we are solving. So in that question we can write A is equal to ZL A cube and A cube is equal to, this is the way in which we can rewrite this. As is simple in cubic units, it is 1. 209 they have given it. What density they have given in kilogram per cubic meter. That we have to convert into gram per cubic centimeter. See that conversion. Density they have given in kilogram per cubic meter. What value they have given? 91.5 kilogram per cubic meter. We can write 1 kilogram is equal to 1000 gram. And we can write 1 cubic meter is equal to 10 raised to 6 cubic centimeter. So we can cancel this. And we can write 91.5 plus 3, this minus 6, so this minus 3 gram per cubic centimeter. So this density is 91.5 into 10 raised to minus 3 gram per cubic centimeter. Avogadro number is 6.022 into 10 raised to 23. This we can add here. And we have to first get A cube here. A cube happens to be 3.793 into 10 raised to minus 21. And that's why A equals to cube root of that 3.793 and 10 raised to minus 21. Cube root of that 1.559 into 10 raised to minus 7 centimeter, which is nothing but 155 into 10 raised to minus 9 centimeter. We can convert that in Indian unit. So this is about the June 19 question paper. March 20, again they have asked question on density. A metal crystallizes in FCC lattice, its length is 0.556 nanometer. Calculate the density of metal. Now 0.556 nanometer is the edge length there. We can calculate that. March 20. In March 20, question number is 50B. They ask us to calculate the density. So as it is, you can read from that question, it is FCC and the atomic mass is 40, they have given that also. This calcium, A cube is 0.556 nanometer. So I have to convert this as 5.56 cube of that, 10 raised to minus 8 cube of that, 6.022 into 10 raised to 23. This is 10 raised to minus 24. This is 10 raised to minus 1. This is 10. So you can just simplify these numbers. It is 1600 divided by 171.87 multiplied by 6.022 is this number remaining, and this will be its answer. The answer is 1.5458. 5458 gram per millimeter is the density in this question. So this is question of March 20. There is one last question, which is July 20, the most recent examination. June 20 is written here, but it also delayed. Related with that, doesn't matter. Silver crystallizes in FCC, edge length is given, density is also given. You have to calculate the atomic mass. So this is question number 52B, June 20. 52B. D is equal to Zm A cube N A. We have to calculate D A cube N A by Z density is already given in that question, isn't it? 10.4 is the density gram per cubic centimeter, and A cube is 4.1 cube of that, 10 raised to minus 8 cube of that. Avogadro number is 6.022 into 10 raised to 23. And what about the value of number of atoms per unit cell, which is 4 here? So you can just simplify this. 10 raised to minus 24. This is 10 raised to minus 1. And if we simplify it, it is 107.9. Either you can write U or you can write gram per. So this is the last question in our question bank which we have solved. So very simple topic for 7 marks. You go through previous question paper and you will realize what are the important points. Make the table, which throughout the topic we are making tables, and remember things, and when the need arises, recall them. I hope that you understood these videos, you have worked on these videos, and the NEET questions, JEE questions, KCET questions will be very easy for you if you do this topic thoroughly. So thank you for patiently watching this video. See you.